Welcome to the second lecture on the first module on the course on advanced marine structures. In the last lecture, we discussed about in the introduction and the scope of this specific course and different modules what we will be covering in this course. In this present module, we will talk about fixed type of offshore platforms, where we discuss gravity platforms, jack-up rigs and jacket platforms. Ladies and gentlemen, it is very important for us to understand different types of marine structures first, so that we understand the structural form and the response behavior of these in general in physical terms, before we understand how to compute the ultimate load carrying capacity and the plastic analysis of these kind of structural systems. So, under this background we will talk about fixed type marine structures in this specific lecture. Now, marine structures are basically the structures which are meant for oil and gas exploration. There are more than about 6,500 installations which are done around the world. They are spread in about 53 countries. These installations are generally built for varied applications and uses. For example, some of them are built for drilling, some of them are meant for preparing water or gas for injecting into the reservoir for improving the recovery or the production rate of the reservoir. Some of these platforms are also meant for processing the oil and gas being explored from the seabed. Some of them are also constructed for cleaning the produced water before they are dispersed into the sea. Of course, these platforms also accommodate lot of residential quarters, what we call them as accommodation facilities. So, marine structures in general are meant for many varied applications, as you see in this slide. Amongst this, let us talk about the first of its nature, what we call gravity based structure, abbreviated as GBS. Now, the gravity based structure are essentially constructed with concrete as a construction material. For example, Condeep is one such platform constructed in concrete. Gravity based structures can also be constructed in steel, but essentially most of them are popularly constructed using concrete as a construction material. One classical example of a gravity platform as on today is Hibernia platform. The photograph of the platform is shown in the slide now for the readers. Gravity platform are essentially constructed for oil production, that is the design objective. Now, let us look into the salient features of this platform. Essentially, these kinds of platforms are large reinforced concrete bottom mounted structure. Essentially, they are very massive and the construction material is reinforced concrete. It uses its own self weight to resist the environmental loads. Remember that these kinds of platforms rest on the sea floor in the self weight, that is why it is called bottom mounted structures. So, therefore, they are not attached to the bottom with piles. There are no requirement of piles on which these platforms will rest. These platforms will directly rest on its self weight on the sea floor. They are essentially suitable to medium depth up to, let us say, 350 meters. That is where people have attempted to construct gravity based structures in the literature. Concrete gravity based structures are constructed with the reinforced concrete as the base. The base includes void spaces, otherwise what we call them as caissons. They are essentially used to provide the structure with a natural buoyancy. This enables the structure to float to the field development location when they are void or when they are empty. Once they reach the installation site, these void spaces are flooded with water. Then the topside modules are lifted and placed in position. The void spaces are then used as storage compartments of crude oil, or sometimes they are permanently filled with iron ores or any other ballast material. The colossal weight of the concrete structures require no foundation piles. Therefore, the name gravity based structure is given to these kind of platforms. There are different varieties of structures constructed, which you can see from the literature: Brent platform, the Ninian platform, the TSG or the Maureen platform. You can see more or less the form which is being used for constructing gravity based structures are similar. The topside details are almost similar in most of these platforms, which essentially contains a drilling rig, the module decks which are meant for drilling, production, exploration, etc. These are the living quarters, and of course the living quarters also houses on the top generally an heli deck for landing purposes of the people. Now the cellar deck is what is required also, which is seen in almost common in all the cases. For example, in the Ninian platform you can see the heli deck is projected out in one extreme corner. The similarity amongst these kinds of platforms which has been constructed is a very large massive base, which you can see in all the three cases. Because of its colossal self weight and massive structure, these kinds of platforms generally rest on the seabed on its self weight. Troll GBS, Troll T300 and Draugen are other classical examples where you can see a large gravity base at the bottom. You can see these are the caissons, which are void spaces in the beginning, which are being used to maintain the buoyancy of these platforms. Further, once the topside is installed and the platform is positioned, this can be used as storage compartments as well. In addition, in certain cases of these platforms, because of its large self weight, they also require what we call skirt piles. Now what is the purpose of a skirt pile? Why steel skirt piles are generally required? Steel skirts are generally required to improve the foundation stability of these kinds of platforms. They also act as erosion resistant members. It assists in proper grouting of the caisson bases, as you saw in the previous slide. It also provides phenomenal resistance to the platform against sliding, what we address as transverse resistance capacity of the platform. The transverse resistance against sliding to the lateral load is phenomenally increased by providing steel skirt piles to these gravity based platforms. In addition to the steel skirt piles, sometimes people also use dowel bars, which are also provided. The dowels extend about 4 meter below the level of steel skirt piles. They also help to prevent damage to the steel skirts if they are provided. There are specific advantages of gravity based platforms which has been seen in the literature. It supports phenomenally large amount of deck loads. It has a very great possible reuse of the construction material. The construction and testing can be completed before the platform is floated to site or towed down to site. That is one of the important advantage, because then you can insist on good quality control on the construction. Generally these kinds of platforms are intended to support very large field for oil exploration. They are useful for what we call a long term production, because these kinds of platforms generally support large number of wells as well. It has got a very large storage capacity. They are more tolerant to overloading and seawater exposure, because in comparison to steel jacket platforms, concrete gravity based structures are less prone to corrosion effects in seawater. Of course, there are some demerits of these kinds of platforms. The cost of these platforms increases exponentially with increase in water depth. Therefore, these kinds of platforms or marine structures cannot be attempted to be constructed in greater water depths. The other important structural problem associated with these platforms are the settlement of foundation. Ladies and gentlemen, as you can understand that these kinds of platforms has a very large colossal self weight, so they create large of impact on the seabed where they are constructed. They are associated with large foundation settlement effects as seen and reported in the literature. As a result of which they also cause what we call sea floor scouring effects. Therefore, these kinds of structures generally require more reinforcing steel than that is required to construct a steel jacket structure. The quantum of reinforcing steel which is being used to make the structure laterally load resistant is phenomenally high, which amounts to increase in cost of these kinds of platforms. If you quickly compare the advantages of gravity platform over jacket platforms, they have greater safety for people on board because they have got high tolerance for lateral loads. Towing to the site with deck is highly possible. Therefore, this kinds of platform minimizes installation time and cost, and of course improves quality control in construction. Of course, these kinds of platform have low maintenance cost because, for example, if gravity based structures are constructed in concrete and they are submerged in water, concrete generally if submerged in water has lesser problems than that of steel structures. These kinds of platforms, because of the larger caesium base they have at the bottom with a wide space, they have got adjustable crude oil capacity, and they have ability to support very larger deck areas and surface loads on the top side. In addition, the risers which are used for exploration and production drilling are protected from the lateral loads because these risers are generally placed inside what we call the central shaft of these kinds of platforms. They also provide possible access to the sea floor because you can see there are large number of caissons which are provided at the bottom through which one can access to the sea floor. It means this amounts to better healthy monitoring of these kinds of platforms from the cellular compartments at the bottom closer to the foundation at the seabed. There are some specific geotechnical problems associated with gravity based structures. What you see in the slide are 4 special critical problems that are closely associated with any massive type of structure which are founded in seabed. Sliding is a problem associated which has lower resistance to lateral load upon the wave or wind load on gravity based structure. Because of the massive colossal weight of the bottom of the structure, it can be subjected to what we call bearing capacity failure, which can initiate a localized failure in the bearing capacity of the soil which supports this kind of structure. The other phenomenal problem what gravity based structures have is what is addressed as rocking. Because of the softer moments created at the support ends of a large colossal weight, there can be a coupled moment generated by the structure and the lateral action of the wave and wind on the platform, which can result in what we call rocking of the platform. Sometimes depending upon the soil condition and the saturation level, you can also address problems related to what we call soil liquefaction, which results in differential settlement of this kind of platform because of its very large colossal weight of these gravity based platforms. You look at the field example, you can see there is one interesting field example which is a concrete gravity based platform which is constructed at Ardenne Point on the west coast of Scotland. You can see these are the towers resting on the caissons which are 24 in numbers, which are very massive in size. This platform was constructed between the period of 1974 to 1978. The total weight of this platform is close to around 300,000 metric ton. At the time of construction, the Cormorant A, which is one of the platform, the other one is you can see here, the Cormorant A was considered to be one of the largest oil production platform ever built during early 80s. The top side of this platform comprises deck of 100 square meter in size. The deck is not shown in this photograph here. It has got a 56 meter high caisson, has a storage capacity of 1,000,000 barrels. It carries towers of 116 meter high. These towers are of about 116 meter high, whereas these caissons are about 56 meter high, which has got a very large storage capacity. This is a closer view of the same platform constructed in 1978 in Scotland. The second type of marine structure which is again meant and constructed for exploration drilling essentially is what we call a jack-up platform. In summary, these kinds of platforms are addressed as drilling rigs in the literature. These are different kinds and photographs of the jack-up rigs taken at different sites during installation. You can see one commonness between all these kinds of jack-up rigs is that it has got the truss type legs. Essentially they are 3 in number, sometimes they are also 6 in number. So essentially they are tripod based structure which has got a deck supported by these 3 legs. Now why it is called as a jack-up? You can see there is a difference between the photograph of this as well as the remaining one. This has been taken intentionally when the deck is being raised or when the legs have been pulled inside to the seabed during commissioning or installation. When the jack-up rig is being towed to the site for exploratory drilling, the deck will be located at the bottom side as you see here, and the legs all will be projected up from the deck. On installation, these legs will be pushed into the seabed and the deck will be lifted up. That is why this is called a jack-up rig. Now most interesting part of this kind of platform is that when the legs are projected in an upward position or when the deck is in the lower position, this can be easily towed from one location to another location. So they are stable when the legs are projected up from the deck. They are also stable when the legs are projected into the sea floor during commissioning or drilling operation. This is a closer view of one of the jack-up rig which is very famously deployed in North Sea, which is Mark's Giant. This will give you a very clear picture about how these legs are protruding the deck and how they are projecting into the sea floor as you see here. There are vital components of the jack-ups which we must understand for our better knowledge on this kind of marine structure. There are different components marked as 1, 2 and so on. I will explain them quickly in the slide here. One is what we call as the derrick, 2 which is located here is what we call as the drawdown works, 3 is the drill floor where this is being located, 4 is the drill pipe which is not explicitly seen in this photograph, 5 is the drill string which is being used as a part of the drilling component, 6 of course is a cantilever projection which comes out of the deck area, and 7 are the legs what we call the jack-up legs or truss based structures, 8 is the living quarter where people are accommodated who work on during the drilling operation, and of course 9 is the heli deck or helipad, and 10 is of course the main deck or the hull on which the hull will be raised, on which whole operation of drilling will take place. And of course 11 is a special component of the leg which we call as a spud can, which is being essentially used for effective foundation of these legs when they are projected into the sea floor for enough stability, which we will discuss in detail in the next slide. If you look at the design objectives of jack-up rigs, essentially they are meant for exploratory drilling. Ladies and gentlemen, there are 2 kinds of drilling which are generally attempted in marine structures. One is what we call drilling for exploration, just to see what is the capability of a specific well in terms of its production capacity. The other is what we call production drilling. Once the exploratory drilling is complete and the yield of the well is established, then a permanent type platform is constructed, then production drilling actually starts. So jack-up rigs are meant for preliminary drilling exercise what we call as exploratory drilling. They are actually similar to barges with movable legs. The rig is towed to the site when the legs are jacked up. After they are towed to the site, the legs are then jacked down to the sea floor and the platform is raised. That is why this kind of platform is given a special name called jack up rigs. They are suitable for shallow water depths only. Maximum operational depth could be up to 140 meters. Of course, there are some specific advantages of jack up rigs when used for exploratory drilling. They are highly mobile, they are stable when the legs are elevated, they have a very low cost operation and they are very highly efficient when they meant for exploratory drilling. There are some demerits of this kind of platforms. They depend on weather windows for placing them. They cannot operate in all kind of sea states and weather conditions. They are restricted only to shallow depths. These platforms are highly subjected to sea floors covering effects. Now blowout can cause collapse of the platform due to what we call soil liquefaction. If you look at the working weather window of this kind of platform, they are capable of course working in harsh environment. The wave heights up to 24 meters can be allowed in this kind of operation. The wind speeds even exceeding 100 knots can also be sustained by these kind of platforms. Ladies and gentlemen, 1 knot is about 1.85 kilometer an hour. They are successful in operating up to water depths of 150 meters. We have already seen some of the components of jack-up rigs. Let us quickly see the main components of a jack-up rig. Essentially, jack-up platforms consists of 3 main components: the hull on which the whole mechanical devices are equipped, the legs and the footing on which the hull rests, and of course the equipments which are used for drilling and production. As I said, it is very interesting to know how these legs are founded in the seabed when they are doing the drilling operation. Spud can is a specific component which is being used for housing or for placing the legs in position in the sea floor. The picture shows you the sand or the spud can which is mounted on a sand or a stiff clay. The spud can is a typical foundation detail which is being used for a jack-up rig. Jack-up rig typically has 3 legs and each one of them has a spud can at its bottom. Each leg is equipped with what we call a shallow conical underside footing which we call the spud can. This is a conical footing located underside of a leg of a specific jack-up rig. This gets penetrated up to a depth of about 2 meters, and because of the hollowness inside, because of the suction pressure, the clay particle or the stiff clay through which this is penetrated gets filled up in this void and this gets locked. Once the spud can is firmly fixed in a sand or a stiff clay, then it is very difficult to plug this foundation out from this oil. You may require very high pull load forces for extracting the spud can foundation from the seabed, which is essentially meant for sand or stiff clay, and remember this kind of spud can foundation is not recommended for hard soil or a rocky bottom. If you look at the operational depth of jack-up rigs in the literature, in early 60s people have been operating these rigs only to depth of about 40 meters. They moved this operational advantages to 150 meters in early 90s. So the use of jack-up rig has motivated people for its successful deployment from a depth of about 40 meter to 4 times of this in a span of about 25 years. Of course, they are also not avoided from accidents. These are some of the photographs which show when the disaster caused a jack-up rig during a storm condition. You can see these are the 3 legs, the helipad, the living quarters, and the derricks and the flare or the cranes which have been actually sinking. You can see this is partly, this completely sink. This has been an accident caused on a jackup rig during a storm, which we address as a disaster. The third kind of marine structure which we address in this lecture will be a jackup platform. The jackup platforms are essentially consist of a superstructure which is referred as topsides in the literature. The topside actually supports a deck which is fixed on the jacket structure. It consists of series of modules which are present on the topside. There are different modules looking for different segmental operation of a jacket structure: drilling equipments, production equipments, gas turbines, generating units, pumps, compressors, flare stacks, revolving cranes, survival craft, helicopter pads, living quarters and catering facilities. These are different kinds of modules which are housed on a topside of a jacket platform, which put together is what we call as a superstructure of a jacket platform. Generally the topside of this structure weighs about 40,000 metric ton. So, typical view, an animated figure of a jacket platform which consists of the derrick mast, the crane, the flare boom, then the helipad, the living quarters and of course what we call as the jacket legs. Essentially this kind of structures are transparent to wave action. What we mean by transparency is the wave is enabled or allowed to pass through the form of the structure. Since they are transparent, the lateral loads exerted on these members are phenomenally reduced in comparison to that of caissons of gravity based structures. So, they are steel jacket platforms. Essentially they consist of a mud mat at the bottom which is housed and supported by a skirt pile on the sides, and there is something called a launch truss which is being used. I will discuss this application separately in the next slide. The legs what you see here is what is called as a jacket structure. Of course there is a boat landing facility available near to the mean sea level or the drought level of this platform. The topside consists of various modules as you just now saw in the previous slide, and of course the topside also houses the crane, the flare boom and the heli deck, as you can see in the schematic view here. This is one of the outline diagram, the free sketch of a typical jacket platform which is being constructed for medium or shallow water depths. This picture shows more detail about the topside. As you understand here, the topside consists of a flare tower, as you see here, which is nothing but a truss based system. It also consists of a drilling rig which we call as a rig tower. It consists of a platform heliport. It also houses different kinds of operational cabins. It has got rig heliport, it has got a rig office and rig cabins which controls the whole drilling rig operation from this sector. It has got restrooms and living quarters. It has got recreational areas as well on the top side. It has got decompression chambers which houses lot of mechanical compression equipments which are used during drilling operation. There are modules and tires where the lifeboats are affixed to this platform. In case of emergency, the people can escape from the platform using the lifeboats. There are different cages and support vessels and test runners or burners which has been used to check the flare boom details of a production well as well. Different modules also contain the power generation units, the control room and the administrative block, and of course an auditorium and TV room. So, it is as good as a self developed township. So, it is a very large in size which houses all basic amenities, recreational facilities, production facilities, technical facilities and of course the details that are required for production of oil from seabed. If you look at the subside details of this, these are all the jacket legs. What we see here is also as a remote operated vehicle to see the positioning of this platform. It has got umbilical cables which are supporting, which are used for the drilling risers. The jacket is what you see here as the legs, and the jackets also has supports derived from the export pipelines and the production pipelines or the product wells which has been used for exploring oil or producing oil from the seabed. These kinds of platforms are generally suitable for water depths up to 250 meters. Of course, the selection of this kind of marine structure depends on the wave climate at a specific site. Jacket surrounds the pile and holds the pile extension in position from the mud line to the deck substructure. It supports and protects the well conductors, pumps, sumps, risers. That is why the legs are otherwise called as jackets. The jacket legs serves as guides for driving of piles. Therefore, some literature also address this kind of platforms as template structures. This is an interesting picture showing you the different components of a jacket type marine structure. It is a drilling derrick, what you see here is a crane, is a heli deck, these are living quarters, these are the main drilling deck module present here. It is an escape capsule which has got lifeboats housed in this. This is a cellar deck which is essentially used for production. These are the deck legs, you can see here the inclined chamfered legs constructed of steel. These are the barge bumpers which are used to protect or to prevent shocks on the legs on impacts of vessels. These are the boat landing modules which are being used. These are the skirt pile guides which are recommended. These are the joint cans as you see here in different locations. These are the braces, X bracing etc., which are used to improve the stability of the jacket legs under lateral loading. These are the pipeline risers which are actually used for production rising. The bottommost set is what we call as the mud mat on which the jacket structure rests. These are the main piles and these are the skirt piles as you see, which can improve the lateral stability of this kind of platform. Interestingly, the launch truss is a vital component of a jacket structure which we discuss in detail. If you look at the components of the jacket platform one by one, heli deck is a raised level platform which facilitates the helipad landing. It houses solar panels which are mounted just below the heli deck to create auxiliary power for production as well as for survival. It contains vent and flare booms. It is nothing but a long truss that supports a vent or a flare line. The top side essentially consists of upper part of the platform which houses most of the equipments. The top side equipments consists of machinery related to process, mechanical, electrical, piping and instrumentation. It also houses generally some form of housing which are meant for people who are working on board. The jacket structure essentially consists of part of the platform which supports the top side and generally it is submerged below the waterline. A jacket is a supporting frame of the platform which is mainly designed to resist the wave loads acting on the platform. Crane pedestal is a large structural tube that supports the offshore crane for lifting purposes. Crane pedestals are function also as diesel storage tanks since the diameter is large enough to house fuel. If you look at the piles and the skirt piles, these are vital components on which the jacket structures rest. Piles are major structural members that are driven through hollow leg tubes to the seabed. It supports the platform in service condition. Piles also connect the jacket structure to the top sides. Skirt piles are essentially required to improve the lateral stability of the platform when the soil is very weak. Skirt piles are generally done in groups of 2, 3 and 4 etc. The transition piece is one of the important segment. It is a structural member which is in the form of a cone which connects the top side to the jacket structure. The jacket structure is nothing but the leg, top side is nothing but the details of the machineries what you saw in the last slide. The top side and the jacket are interconnected by a piece which is conical in shape which locks the deck to that of the legs. This piece is what we call a transition piece. It is a cone shaped design piece which is preferable as the leg size of the top sides are smaller in diameter compared to that of the jacket legs. Conductors are long, hollow, straight or curved tubes that embed into the seabed through which the drilling is performed. To support such long length of the tubes, conductor framings are also provided, which also acts as lateral support guides to the conductors which receive support and strength from the jacket legs. Risers are nothing but long slender tubes that carry the crude oil or partially processed oil to another location for further processing. Risers are generally clamped to the jacket structure and they receive support from the jacket legs only. If you look at the boat landing, barge bumpers and riser guards, these are also ancillary components of the platform which are required for berthing of the supply vessels. To facilitate a smooth berthing, barge bumpers are installed on each side of the boat landing. This reduces the vessel impact on the jacket structure. The riser guard also protects the oil and gas carrying risers. They are also designed for accidental vessel impacts caused by these vessels on the risers. Launch truss is one of the vital component. Sometimes when the jacket structures are very large in size and cannot be lifted even with large cranes, they are done in part and parcel. The permanent structures like launch trusses will be provided on one side of the jacket to facilitate the loading out on the jacket to the barge. If the jacket is designed for a buoyancy, then the jacket is launched to the sea after reaching its position for a natural append and leveling operation. When the jacket is launched, it afloats on its own because of the buoyancy design. The jacket legs are then sequentially flooded to make it upright and stand over the seabed before the piles are driven through the legs to fix it to the seabed. The launch truss actually helps in skidding the jacket from the barge to the sea on site of location or installation. Mud mat is one of the vital component of this kind of structure, which is the bottommost frame of the platform, which helps in improving stability against lateral forces before the piles are driven through the legs. It is similar to a large raft made out of timber. It helps the platform to sink deeper if the soil is too soft. It provides adequate resistance against overturning in case of any installation problems. Jacket platforms are essentially production type platforms. It consists of steel framed tubular structure which is attached to the seabed with piles. It is constructed in sections and transported to the site. The design lifetime of these kind of platforms is about 10 to 25 years depending upon of course the yield of the well. The salient advantages of these kind of marine structures are it supports large deck loads, it may be constructed in sections and transported, and supports large field, and it is essentially meant for long term production because it can support large number of production wells as well. Piles result in good stability against lateral loading. They have very little effect on sea floor scoring unlike gravity based structures. There are some disadvantages of this kind of marine structures. The cost of these structures increase exponentially with increase in water depth. They have very high initial and maintenance costs. They are not mostly reusable. The steel structural members are subjected to extensive corrosion in the sea environment. Therefore, corrosion protection measures becomes very important and they are also expensive. So, in this present lecture we discussed about 3 types of marine structures: gravity based structure, jack-up rigs and fixed type jacket structures, which are essentially meant for exploratory or production type of drilling operations. We have also seen the important components which are consisting or comprising these kind of structures. It is better that we understand these kind of structures in detail before we start discussing the ultimate load carrying capacity of these members under combined action of wind, wave, current and seismic loading. Thank you.